Hello friends. Welcome to Boss School. Today we are starting Chapter 1 of Class 11 Chemistry, some basic concepts of chemistry. This chapter lays the foundation for everything you'll learn in chemistry, so let's dive in. Chemistry is the study of matter and its interactions. Matter is anything that has mass and occupies space. Everything around us, air, water, metals, food, is made of matter. Atoms and molecules are the basic building blocks of matter. Chemistry plays a vital role in our lives. For example, drugs like cisplatin and Taxol are used in cancer therapy. Azithromycin, or AZT, is used to treat AIDS. Everyday items like soaps, alloys, polymers, and acids are all products of chemistry. Now let's talk about the states of matter. Matter exists in three states: solid, liquid, and gas. In solids, particles are closely packed in an ordered manner. They have definite shape and volume. In liquids, particles are loosely packed and can move around. Liquids have definite volume but no fixed shape. They take the shape of the container they are kept in. In gases, particles are far apart and move freely. Gases have neither definite shape nor volume. Gases occupy the total volume the container they are kept in. These states are interconvertible. By changing temperature and pressure, solids can become liquids, and liquids can become gases. Cooling reverses the process. When solids turn to liquid, the process is called melting or liquefaction. When liquids turn to gaseous form, the process is called vaporization. This happens when we heat the substance. The reverse happens when we cool. When gases turn into liquids, the process is called condensation. When liquids turn into solid, the process is called solidification. Sublimation is when a solid directly turns into gas, and condensation is when gas turns into liquid. Matter is classified into mixtures and pure substances. Mixtures contain two or more substances mixed in any ratio. They can be homogeneous or heterogeneous. Homogeneous mixtures have uniform composition like sugar solution, air, or milk. Heterogeneous mixtures do not have uniform composition like salt and sugar mix, or grains with dirt. Pure substances are of two types: elements and compounds. Elements consist of only one type of atom. Examples include sodium, copper, and silver. Molecules of elements like nitrogen, hydrogen, and oxygen are formed when atoms combine. Compounds are formed when atoms of different elements combine in a fixed ratio. Their properties are different from the elements they are made of. For example, hydrogen supports combustion, oxygen helps fire, but water made of hydrogen and oxygen is a fire extinguisher. Every substance has physical and chemical properties. Physical properties include color, odor, melting point, boiling point, and density. These can be measured without changing the substance. Chemical properties include composition, combustibility, and reactivity. Measuring these involves a chemical change. To measure properties, we use units. Earlier, different systems were used: English and metric. Now, the International System of Units, or SI, is used worldwide. There are 7 base quantities: length, mass, time, electric current, temperature, amount of substance, and luminous intensity. Their units are meter, kilogram, second, ampere, Kelvin, mole, and candela. We have already learned this SI system in our first chapter of physics, units and measurements. We also use prefixes to express very large or very small quantities. For example, kilo means thousand, mega means million, and giga means billion. On the smaller side, milli means 1,000th, micro means 1,000,000th, and nano means 1,000,000,000th. These are required for conversion of units and efficient expression of numerical values. Now, let's understand mass and weight. Mass is the amount of matter in a substance. It is constant. Weight is the force of gravity acting on mass. It can vary depending on location. Mass is measured in kilograms, and weight is measured in newtons. Volume is the space occupied by a substance. It is measured in cubic meters or liters. In labs, we use burettes, pipettes, graduated cylinders, and volumetric flasks to measure volume. Density is mass per unit volume. It tells us how tightly particles are packed. The SI unit is kilogram per cubic meter. In chemistry, we often use grams per cubic centimeter or grams per milliliter. Temperature is measured in Celsius, Fahrenheit, or Kelvin. Kelvin is the SI unit. The formulas are Fahrenheit equals Celsius times 9 by 5 plus 32. Kelvin equals Celsius plus 273.15. In chemistry, we deal with very large or very small numbers. To handle them, we use scientific notation. For example, 6.022 times 10 to the power 23 is Avogadro's number. Let's learn the rules for arithmetic with scientific notation. In multiplication, we multiply the numbers and add the powers of 10. In division, we divide the numbers and subtract the powers. In addition and subtraction, we first make the powers of 10 equal, then add or subtract the numbers. Significant figures are digits that carry meaning in a measurement. They include all certain digits and one uncertain digit. We have already learned about these significant figures in the first chapter of physics. Everything is literally same. If you have watched the lecture, you must know the rules to determine the significant figures. The rules are all non-zero digits are significant. Zeros between non-zero digits are significant. Leading zeros are not significant. Trailing zeros are significant only if there is a decimal point. In addition or subtraction, the result should match the least number of decimal places. In multiplication or division, the result should match the least number of significant figures. Rounding off follows simple rules. If the digit to be dropped is more than 5, increase the previous digit by 1. If it is less than 5, leave it unchanged. If it is exactly 5, increase the previous digit only if it is odd. Dimensional analysis helps convert units and check equations. For example, to convert 14 meters to centimeters, multiply by 100. You get 1400 centimeters. Now let's learn the laws of chemical combinations. First is the law of conservation of mass. Mass can neither be created nor destroyed. Second is the law of definite proportions. A compound always contains elements in the same ratio by mass. Third is the law of multiple proportions. If two elements form more than one compound, the ratios of masses are simple whole numbers. Gay-Lussac's law states that gases combine in simple ratios by volume. For example, 100 milliliters of hydrogen combine with 50 milliliters of oxygen to form 100 milliliters of water vapor. Avogadro's law says equal volumes of gases at same temperature and pressure contain equal number of molecules. Dalton's atomic theory says matter is made of indivisible atoms. Atoms of the same element are identical. Atoms combine in simple ratios to form compounds. Chemical reactions involve rearrangement of atoms. This last postulate of Dalton's atomic theory is similar to law of conservation of mass. Limitations of Dalton's theory include it couldn't explain gaseous volumes, atomic masses, or bonding forces. Now, let's learn atomic masses and molecular masses. Atomic mass is the mass of an atom. It is measured relative to carbon-12. One atomic mass unit is 1/12 the mass of a carbon-12 atom. It is now called unified mass or U. Average atomic mass is the weighted average of isotopes. Isotopes are atoms of the same element with different masses. Molecular mass is the sum of atomic masses in a molecule. For example, water has 2 hydrogen atoms and 1 oxygen atom. Its molecular mass is 18.02 unified mass. Formula mass is used for compounds like sodium chloride, which don't exist as molecules. Sodium chloride has a formula mass of 58.5 unified mass. One of the most important topic in chemistry is the mole concept. The mole is a counting unit in chemistry. 1 mole contains 6.022 times 10 to the power 23 particles. The molar mass in grams is equal to the molecular mass in unified mass. Percentage composition tells us how much of each element is present in a compound. It is calculated using the mass of the element and the molar mass of the compound. Empirical formula shows the simplest ratio of atoms. Molecular formula shows the actual number of atoms. To find molecular formula, divide molar mass by empirical formula mass. Stoichiometry deals with the quantitative relationships in chemical reactions. It helps us calculate reactants and products using balanced equations. Limiting reagent is the reactant that gets used up first. It limits the amount of product formed. The other reactants are called excess reagents. Concentration of solutions can be expressed in different ways: mass percent, mole fraction, molarity, and molality. Mass percent is mass of solute in 100 grams of solution. Mole fraction is ratio of moles of one component to total moles. Molarity is moles of solute per liter of solution. Molality is moles of solute per kilogram of solvent. Molality is independent of temperature. Let's revise the key points. Chemistry studies matter and its properties. Matter exists in 3 states. It is classified into mixtures and pure substances. Units and measurements are essential. Laws of chemical combinations explain how elements form compounds. Atomic and molecular masses help us understand composition. The mole concept is central to calculations. Concentration tells us how strong a solution is. Before we end, here are some important questions to practice. Definitions of key terms. Limiting reagent calculations. Empirical and molecular formulae. Laws of chemical combination. Dalton's atomic theory. Significant figures. Relative abundance calculations. That was Chapter 1, some basic concepts of chemistry. If you found this helpful, please like, share, and subscribe to Boss School. The next chapter will be on structure of atom. Press the bell icon so you don't miss it. All the best for your studies. Keep learning, keep scoring.